Have you ever thought, why is space black? This is because there is a layer of atmosphere around the Earth, which can reflect light and make the sky appear blue. However, atmospheric elements also escape into space, which will cause the atmosphere to gradually disappear. So what are the ways to escape from the atmosphere? Let's imagine that if the atmosphere is a person, its escape layer is like the skin of the human body, and the moisture will be continuously lost every day, but our skin will not become weaker and weaker. Why is this? Because our body has the ability to repair and regenerate. Similarly, the atmosphere also has a mechanism of self-repair. It will continue to regenerate new gas through various chemical reactions to make up for the loss of the escape layer. In addition, the gravity of the Earth also has a great effect on the pressure of the atmosphere. It makes it impossible for gas molecules to leave the surface of the Earth and maintain the stability of the atmosphere. Therefore, although the gas molecules of the atmospheric escape layer are constantly losing to space, the air pressure on the Earth will not decline. Let's take a look at a common example of life: the escape of water vapor in boiling water. When we boil the water, water steam began to generate water on the water surface. These water vapor is constantly moving at high temperatures. Because water vapor molecules are faster than water molecules, some water vapor molecules will overcome the gravity of the water to escape from the water surface, thereby entering the air. This process is the process of escaping of water vapor. Similarly, the atmospheric escape is also because the gas molecules in the atmosphere get enough speed, thereby overcoming the process of the gravity of the Earth into space. Atmospheric escape means that the gas molecules in the atmosphere obtain sufficient energy through thermal movement, light radiation, and ionization, thereby overcoming the gravity of the Earth into space. Here we will introduce the three main ways of escaping atmosphere. The first is the hot escape. This escape path means that the speed obtained by the gas molecules in the atmosphere is sufficient to overcome the gravity of the Earth and escape into space. Similar to the process of escaping the water vapor in boiling water we just mentioned, it only requires higher temperatures in the atmosphere to occur. Followed by the light escape. This escape means that the gas molecules in the atmosphere are affected by the energy of the solar radiation and get enough speed to escape into space. For example, in the aurora area of the Earth, the high-energy electronics brought by the sun collide with the gas molecules in the atmosphere, so that they can get enough speed to overcome the gravitational escape. Finally, the escape from the electrical departure. This escape means that the gas molecules in the atmosphere are affected by the external energy of the solar radiation, which is lost or obtained into an ion. Under the action of the Earth's magnetic field, these ions will be accelerated and escaped into space. This escape approach is particularly significant for light elements such as hydrogen and high in the atmosphere, because their ionization can be relatively low. The principles of these three ways to escape may be a bit abstract, but simply speaking, they all get enough energy by allowing the molecules to overcome the restraint of the gravity of the Earth and escape from the atmosphere. So what impact will atmospheric escape affect the Earth? It will cause the atmosphere to become thinner and the loss of ozone layer, which will increase ultraviolet radiation, which will have a negative impact on the climate and environment of the Earth. On other planets, the atmosphere of the planet with a high escape rate will gradually disappear, making it impossible to maintain the conditions of liquid water and life. So why has the atmosphere of the Earth never changed? It turns out that the steady-state balance mechanism of the Earth's atmosphere plays an important role. This balance mechanism means that the input and output of the gas in the atmosphere reaches a balance, thereby maintaining the stability of the atmospheric pressure. So, how is this balance process realized? First of all, the atmosphere escape and the new gas input are balanced. Atmospheric escape refers to the process of getting a sufficient speed of the atmospheric molecules to overcome the gravity through the heat movement and enter the space outside the gravity of the Earth. The new gas input comes from various factors, such as volcanic activity and vegetation breathing. Secondly, in order to better understand this balance, we can compare it to a bucket. If the speed of adding water from the bucket to the inside is equal to the speed leaked from the bottom of the barrel, the water level in this bucket will not change. Similarly, if the input and output speed of the gas in the atmosphere reaches a balance, the atmospheric pressure of the Earth will never change. Finally, Let's take a look at the anthropomorphic description of this balance process. We can compare the atmosphere as an oxygen, and the new gas input is his breathing. If his breathing speed is equal to his body's oxygen, his body will maintain a balanced state without feeling tired or hypoxic. Similarly, if the input and output speed of the gas in the atmosphere reaches a balance, the atmospheric pressure of the Earth will always be stable. We have been discussing the escape of the Earth's atmosphere and understand how this phenomenon affects the Earth. Judging from what we know, the steady-state balance mechanism of the Earth's atmosphere has maintained its air pressure. We know that the atmospheric escape is an important part of this balance mechanism. Through a variety of ways such as hot escape, light escape, and electrical escape, it continues to lose the gas of the Earth's atmosphere. However, the new gas input comes from the natural processes such as volcanic activity and vegetation breathing, so that the atmosphere maintains a balanced state. Although this balance looks stable, the escape of the atmosphere has an important impact on the environment and climate of the Earth. It can lead to the loss of ozone layer and enhancement of ultraviolet radiation. In addition, through other planets we have discussed, we also know the harmfulness of the atmosphere escape. For example, Mars has lost part of its atmosphere, which has led to a sharp decline in the temperature of Mars on the surface, which makes Mars become colder and dry. Therefore, we must work together to protect the Earth's environment and maintain the steady-state balance of the atmosphere. In this period of popular science video, we discussed why the Earth's atmosphere has never changed. By understanding the steady-state balance mechanism of the atmosphere, we find that this balance is maintained through the atmosphere escape and the balance of new gas input. At the same time, we also introduced some new sources of gas input, such as volcanic activity, vegetation breathing, etc. Through anthropomorphic ways, we vividly describe this balance process, allowing the audience to understand the operating mechanism of the atmosphere more deeply. However, we also emphasize the harmfulness of the atmosphere escape and call on the audience to protect the Earth's environment together. At the end of this issue, we want to ask the audience a question: will the atmospheric escape and the balance of the new gas input be destroyed? This is a question worthy of our thinking, because it is directly related to the ecological environment of the Earth and the future of human beings. We need to actively participate in environmental protection actions and contribute to the future of the Earth. Let's act together and take care of our Earth together.